So, you probably already know what a 3D model is, but this video will be about the many parts that make up a model, and then how they can be animated to move about. Although my area of expertise is in 3D graphics, I'm going to try and keep away from the actual rendering process and focus more on the model data itself. So here we have a 3D model, but other than an interesting shape, what is a 3D model? Simply put, it's triangles. Lots and lots of triangles. These triangles are referred to as faces, and every face is defined by 3 vertices, which are just points in 3D space. This is true for nearly all 3D models, the only exception being if you're using a rather weird rendering technique. However, the triangles also need some extra information, such as a texture for colour and a normal for its direction. In order to draw a texture over the triangle, we include an X and a Y position from the texture at each vertex on the triangle. Using these texture coordinates, we can then look up the colour on the texture for each pixel that the triangle takes up on the screen. The normal is just a direction, and unless you are manually writing fancy lighting shaders, like I do, you don't need to know much about them. Just think of them as an arrow coming straight out from the triangle. So that's a model. But what about animations? Well, before we can talk about animations, we need to talk about skeletons. No, not the ones found in a cemetery, but a collection of nodes that define how a model can move. These nodes, often called bones, hence the name skeleton, are placed in a hierarchy across the model at pivot or movement points. Once you have a skeleton, you can then perform a technique called rigging, where each vertex is assigned to one or more bones, then when these bones are moved, the vertices are also moved. The skeleton itself is a simple hierarchical structure of bones, and each bone is just a point in space. Unlike the vertices from the model, however, each point is defined by the one before it. For example, the hand bone is in a position relative to the arm bone, and the arm bone is relative to the shoulder. This is very important for the mathematics required when moving the bones, so that moving the arm affects the position of the hand. So now we have our skeleton and our model which has been rigged to it. It's time to add some animation. Unlike models, there are many ways to create an animation. For every frame we can describe what position all the bones are in, which is a lot of hard work. Or we can define a few key positions and have the in-between frames be an estimate. These are called keyframes, and you'll see them in everything from 3D animated movie to a Flash application. The animation itself is simply a collection of these keyframes spread out over time, and then when rendering, we sample these keyframes to figure out the position of each bone each frame. Now, there is one more important feature that I didn't mention when talking about the model. Each triangle is assigned to a material that describes what texture is applied to that face, along with a bunch of lighting values. The only reason I mention the materials is that I also use them to define my collision shapes. Since you can name a material, I can call it collision, and then when my engine reads that material, it knows that all the triangles with that material should be treated as collision instead of drawn to the screen. This will be more relevant when I'm talking about the collision in a future video. Now it comes to saving this data to a file, and there are heaps of different file types to choose from. Some are open and some proprietary. The most basic file for 3D models is known as Wavefront, with the extension .obj. What makes this file type easy for beginners is that it is just a text file, so it can be opened in something like Notepad to see the model data. However, OBJ cannot store animations or skeletons, which makes it unsuitable for this project. For my engine, I'm using Collada, as it can store everything I talked about above and is natively supported by Blender since version 2.6. The only downside to using Collada is that the Blender exporter only supports a single animation per file, which is important when it comes to implementing the animations, as you want multiple animations affecting one object. For example, a door would have an open animation and a close animation, and with the file setup I need to include both of those within one animation. Since this video is already getting quite long, and there's still lots to talk about when it comes to actually implementing all this stuff into the game engine, I'm going to break this up and talk next week about the implementation. Thanks for watching.